Hello, welcome dear student in the first lecture of Ionic Equilibria. In the last lecture, we have completed or we have successfully completed the thermodynamics by the Shinde sir. Now, we are going to study the new topic for the MST-CET, that is Ionic Equilibria. रेग्युलर क्लासमध्ये आपण आयोनिक इक्विलिब्रिया हा टॉपिक सुरू केलेला आहे. आज आपण MST-CET ला त्या टॉपिकला सुरुवात करूया. सुरुवातीला आपण काय बघितलं होतं, तो जो काही पार्ट आहे म्हणजेच इंट्रोडक्टरी पार्ट, त्याच्यानंतर आयोनायझेशन ऑफ एन ऍसिड अँड बेसिस, दॅट मीन्स द डिग्री ऑफ dissociation or the degree of ionization, and what are the acids and bases, that is the concepts of acid and bases we have revised in the first MST-CET lecture, and after that we have discussed some MCQs on that revised part. So let us start with the revision of the topic Ionic Equilibria. Dear student, first of all, what is mean by Ionic Equilibria? The Ionic Equilibria, the word itself, it is divided into two parts. Ionic, it is associated with the ions, and equilibria means there is an equilibrium exists between the someone. That means what is mean by Ionic Equilibria? Ionic Equilibria is defined as the equilibrium that is exists between ions and its undissociated molecule is called as a Ionic Equilibrium. That means the equilibrium which is established between the ions and the unionized molecule is called as a Ionic Equilibrium. But how the ions are formed? Ions are formed from their parent atoms. How the ions are formed? And ions means what? Ions are the charged species. Ions are the charged species. Either they carry a positive charge or they carry a negative charge, and they are formed correspondingly their parent atom, and therefore there is a difference between atom and ion, because when the atom loses or gain the electron, then at that time the ions are formed. Ions are two types, cations and anions. Cations are formed by the loss of electron from the parent atom, and therefore it acquires a positive charge. And anions are formed by the gain of an electron, and therefore the anion it having a negative charge. And therefore the ions are the charged species, that means it is having either positive charge or a negative charge. Then what are the electrolytes? What are the electrolytes? When electricity, if we consider in one of the example, for example NaCl, if we consider the NaCl as an electrolyte, and when we pass the electricity through them, then it dissociated into its ions. That means the dissociation of NaCl takes place, and how it can be concluded? Because the electricity is passed through them. Electricity is passed through them, and therefore the NaCl are the electrolytes. What are the electrolytes? Electrolyte whose aqueous solution conducts the heat and electricity are called as electrolytes. Are called as electrolytes. And dear student, remember that all the salts formed from acid and bases, that is from the simple neutralization reaction, all the salts are electrolyte. All the salts are electrolyte. Then what are the non-electrolyte? Non-electrolyte means whose aqueous solution does not conduct the heat and electricity. For example, benzene, sugar, urea. When we pass the electricity of the aqueous solution of all these, then it does not conduct the heat and electricity. And therefore, these are the example of a non-electrolyte. Then we have focused in this topic with the electrolyte. Then we have defined electrolyte as electrolyte are the substances which gives rise to ions when it dissolved in water. What are the electrolytes? Electrolytes, when it dissolved in water, it dissociated into its ions and conduct the heat and electricity, and they are called as electrolyte. Further, the electrolyte are classified as electrolyte are classified as strong electrolyte and weak electrolyte. Strong electrolyte and weak electrolyte. Electrolyte are classified as strong electrolyte and weak electrolyte. Then what are the strong electrolyte? A strong electrolyte whose aqueous solution or which dissociate completely into its ions. Strong electrolytes are dissociated completely. This is a very important word, that is completely. Strong electrolyte dissociated completely into its ions. For example, if we take the example of an HCl, then it dissociates completely into its ions as H plus and Cl minus. This is the strong electrolyte. Then what is mean by weak electrolyte? Weak electrolyte which dissociate incompletely or partially. Weak electrolyte which dissociated incompletely or partially is called as a weak electrolyte. For example, NH4OH which dissociated partially or incompletely, and it is indicated by this arrow, and it is written as NH4 plus OH minus. This is one of the example of a weak electrolyte. A weak electrolyte which dissociate partially or incompletely, and henceforth there is a equilibrium which exists between ions and undissociated molecule is called as ionic equilibria or ionic equilibrium. Here in the weak electrolyte there is an exist of an equilibrium between the ions and undissociated molecule. But what about the strong electrolyte? The strong electrolyte which dissociated completely, and therefore the concentration of HCl it becomes zero, means all the molecules and therefore here the concentration of HCl becomes 0 and the concentration of H plus and Cl minus is in that reaction or in that solution. But for the weak electrolyte, it dissociates partially, means if initially we take the 100 moles of this weak electrolyte, then at that time only a few molecules of this weak electrolyte it get dissociated. And therefore such molecule are called as a weak electrolyte. So the electrolytes are classified as a strong electrolyte and a weak electrolyte. For example, all strong acids and bases and the salts are strong electrolyte. What are the example of a strong electrolyte? All strong acids, strong bases and all the salts derived from acid and bases are the strong electrolyte. In weak electrolyte, weak acid and weak bases are the weak electrolyte. Weak acid and weak bases are the weak electrolyte. So this is the introductory part of the topic ionic equilibrium. So what are the electrolyte whose aqueous solution conducts the electricity are called as electrolyte. What are the non-electrolyte? Non-electrolyte whose aqueous solution does not conduct the electricity. That means the molecule that does not get dissociated into its ions. Further, we have only studied the electrolyte. Electrolyte are classified as strong electrolyte and a weak electrolyte. All strong acids, strong bases and the salts are a strong electrolyte. Weak acid and weak bases are the weak electrolyte. So, what is next? Next, we have to revise what is mean by degree of dissociation. What is mean by degree of dissociation? What is mean by degree of dissociation? The degree of dissociation. The degree of dissociation is defined as it is the fraction of total number of moles of an electrolyte that dissociated when the equilibrium is reached. We have to remember the definition of the degree of dissociation, because after some time we have to discuss some MCQs on this revised part of the ionic equilibrium. What is mean by degree of dissociation? The degree of dissociation is the fraction of total number of moles of the electrolyte that dissociated into its ions is called as a degree of dissociation. For example, if we take the weak acid or a weak base which dissociated partially or incompletely. For example, if we take the weak acid, as acetic acid is a weak acid which dissociated partially or incompletely, and therefore the equilibrium reaction is written by using this double-headed arrow. Therefore, it forms the acetate ion and the hydrogen ion. Acetate ion and the hydrogen ion. Suppose initially here we have 100 molecules of acetic acid. As the acetic acid is a weak acid, that means a weak electrolyte which dissociate partially or incompletely into its ions, and therefore initially if we take, what is the initial number of mole to dissociate it? It is equal to 0, 0. But as the time passes, how many number of moles out of these 100 moles that get dissociated? Then firstly it dissociated the 10 molecules. If the 10 molecules they get dissociated, then after some time 20 molecules they get dissociated. After some time the 30 molecules they get dissociated. But at one point, as we see in the chemical equilibrium, that is our 11th standard topic, there is an equilibrium, because the further dissociation or the ionization of this molecule is stopped here, and there is an existence of the equilibrium between these ions and these unionized species. These ions and these unionized species is called as ionic equilibrium. That means, how to define the alpha from this? Alpha is the degree of dissociation. That means the degree of dissociation is denoted by a letter alpha, which is equal to the number of mole dissociated. Number of mole dissociated to the total number of mole. Number of moles dissociated to the total number of mole. And therefore here, what is the total number of moles? That is the initial number of moles 100. And if the 10 number out of 100, the 10 number of moles it can be dissociated. That means what is the alpha? Alpha is the number of mole dissociated out of the total mole, and therefore how we can define the alpha means the degree of dissociation. The degree of dissociation alpha, which is equal to, it is the fraction of total number of moles of an electrolyte that dissociated when the equilibrium is reached, and the equilibrium is exists in the weak electrolyte, in the weak acid or in the weak basis. So alpha, which is equal to what is? It is equal to 0.1 for this reaction. Alpha, it is equal to 0.1. Then for the strong electrolyte, what is the value of alpha? For the strong electrolyte, suppose if we take a strong electrolyte which dissociated completely, for example NaOH is a strong electrolyte which dissociated completely into its ions, that Na plus and OH minus. If we take initially the 100 moles of NaOH, it is a strong electrolyte. Therefore out of 100 all the molecules they get dissociated, that means forms 100 Na plus and 100 OH minus, as it is a strong electrolyte. Then what is the value of alpha for the strong electrolyte? Out of 100 mole, how many get dissociated? 100, and therefore it is equal to 1. So dear student, always remember that for the strong electrolyte, alpha which is equal to 1, but for the weak electrolyte which dissociate incompletely, partially, the value of alpha is always less than 1. That means it is in the fraction. fraction. That means it is in the fraction. You have to remember this thing about the degree of dissociation. Then what is mean by percent alpha? Percent alpha means alpha into 100. This is a very important formula for the exam point of view. When we solve the MCQs in some next lecture, then what is the percent alpha, which is equal to alpha into 100, and therefore from the percent alpha, if we want to calculate the alpha, then alpha which is equal to percent alpha divided by 100. Alpha which is equal to percent alpha divided by 100. Means if we have the percent alpha and we want to calculate the value of alpha, that means the degree of dissociation, then what is the formula for that? Alpha which is equal to percent alpha divided by 100. Percent alpha divided by 100. This formula is very important from the example point of view. So next we have to revise a main concept from the ionic equilibrium is the concept of acids and bases. Concept of acids and bases. As from the earlier knowledge, that is from the classical theory of or the classical concept of acid and bases, what we have to say? Acid is aqueous solution turns blue litmus red. Acid which turns the blue litmus red. Bases which turns the red litmus blue. Then acid which neutralize the base, or base which neutralize the acid. These are the definition of acid and bases from our classical concept. But the classical concept, they have some drawbacks. And therefore means it unable to explain the actual causes of behavior of an acid and bases. The classical concept, it could not explain the actual behavior of an acid and bases. So we have to discuss the ancient or the modern concept of acid and bases, and therefore in the modern concept of acid and bases we have to study the three theories for the acid and bases, and in that we have to revise the first theory of acid and bases is the Arrhenius theory. The first theory is Arrhenius theory. According to this theory, what is an acid and what is mean by base? According to Arrhenius theory, an acid is a substance when it dissolved in the water, means whose aqueous solution produces the H plus. H plus means the hydrogen ions. An acid is a substance which produces the H plus ions in water is called as an acid. And according to the Arrhenius theory, a base is a substance which gives rise to OH minus ions in an aqueous solution. Means this theory, it defines the acid and bases as an acid which gives the H plus ions in an aqueous solution, and the base which gives the OH minus ions in an aqueous solution. So these are the definition of acid and bases according to according to the Arrhenius theory. It is a very important point to remember you from the MCQ's point of view, and therefore according to the Arrhenius theory, acid gives the H plus ions and the base gives the OH minus ions. But there are some drawbacks or the limitations of this Arrhenius theory. That means it could not explain the basicity of the substances which do not having the OH minus or which do not having the OH group. So the new concept from the scientist Lowry and Bronsted explain the acid and bases to overcome the limitations of the Arrhenius theory. And according to the Lowry and Bronsted acid-base concept, an acid is a proton donor. An acid is a proton donor, and a base is a proton acceptor. An acid is a proton donor and a base is a proton acceptor. And by donating a proton and by accepting a proton, it forms a conjugate acid-base pair. It forms a conjugate acid-base pair. So we have discussed the conjugate acid-base pair here in a detail. For example, HCl plus NH3. For example, HCl plus NH3. It forms the NH4 plus Cl minus. Means when HCl react with the ammonia, it forms the NH4 plus ions plus Cl minus ions. This is the acid. This is the base. As from our previous knowledge, HCl is an acid which gives the H plus ions, and it donates a proton. It donates a proton to this NH3, and NH3 accept a proton, and therefore according to the Lowry and Bronsted theory, further it is not having the OH minus group. It is a base because it is a proton acceptor from the acid. HCl is an acid according to the Arrhenius theory because it produces the H plus ions and it donates a proton. Proton means the hydrogen ion. Means this is the proton donor, this is a proton acceptor, and this is the acid according to the Arrhenius theory and as well as the Lowry and Bronsted theory. But this is the base according to the Lowry and Bronsted concept. Therefore, by donating and accepting a proton, this is an acid and this is a base. And therefore, here one conjugate or the two conjugate acid-base pairs are formed. That is HCl, it forms the Cl minus, and NH3, forms the NH4 plus. HCl and the Cl minus, here HCl and the Cl minus. HCl is an acid and this is a conjugate base of this acid. This is the conjugate base of this acid. This is a base and this is a conjugate acid. So always remember that the conjugate acid-base pair which is differ only by one proton. That means here what is the difference in these two? Only by one proton. The difference in this conjugate acid-base pair is only one proton. If this is the base, then this is the conjugate acid of this base. Because the conjugate acid having one proton more than the base, and conjugate base having one proton less than their acids. This is a very important concept for the exam point of view or from the MCQ point of view. What is mean by conjugate acid base pair? By donating and accepting a proton in that reaction, it forms the two conjugate acid base pair. If this is an acid and this is the conjugate base, that is the conjugate base is having one less proton and conjugate base having one less proton and conjugate acid having one more proton. We have to discuss some more example in the MCQs. Next, but also there are some limitations of this theory, and therefore a third theory, that is a Lewis theory, is introduced, and according to the Lewis theory of acid and bases, how we define the acids and bases according to the Lewis theory. An acid is a lone pair acceptor. Acid, lone pair acceptor, and bases are the lone pair donor. Bases are the lone pair donor. For example, if we consider the BF3 and here, if we consider the BF3 and NH3, and according to the Lewis acid, BF3 is a lone pair acceptor because boron, and in the fluoride, boron having this incomplete octet. It is having a incomplete octet, and therefore there needs to electron to complete the octet, and therefore acid, according to the Lewis theory, BF3, AlCl3, then SiCl4, these are some examples of an acids. And base is a lone pair donor, that means ammonia. In ammonia, nitrogen contains one lone pair, and it donates the lone pair to this BF3, and it forms a bond. Then it forms here the bond called as a coordinate covalent bond. It forms a bond called as a coordinate covalent bond. Means in the Lewis theory, which type of bond is formed between the acid and bases? Forms a coordinate covalent bond. So, dear student, these are some, in the regular lecture we have discussed this in detail. So, you have to see the regular lecture. With that, this is the first revision lecture of the introduction, degree of dissociation, and the acid-base concept. So, we have discussed some MCQ